All right, in this video, we're going to actually walk through an example to find the profit maximizing quantity and price for a monopoly firm. We're also going to find the profit, and we're going to compare that profit to what the profit would be for a output level that's different from Q star. One that's 100% less, like 100 units less, 100 units more. Now, remember, first things first, once you see a question that's asking you to calculate something for profit max, your mind should immediately go to MR is equal to MC, right? And we can get MR from this, marginal revenue from this, because marginal revenue is a derivative, right, of total revenue with respect to Q. And total revenue is just P times Q, right? So if we have P, we can just multiply by Q. Wonderful. And marginal cost we can get from this because that's the derivative of total cost with respect again to Q. Wonderful. So we have all our parts here. Let's go ahead and get started. So we're going to start with part A, which is asking us to find that profit maximizing quantity and price. Please remember, we have to start with quantity just given the nature of our equation. Okay, so let's go ahead and get started. So we have part A here. We need MR is equal to MC. Let's find MR. If total revenue is equal to price times quantity, and price is 1,000 minus Q, 1,000 minus Q, and then quantity is just Q, right? This would be 1,000 Q minus Q squared. I'll try to go through this step by step, which might make this video a little longer, but I do think that it's worth it. Feel free to go faster when you're watching it, right? The speed of 2x. Okay, so we have that marginal revenue is, remember, it's just how will total revenue change, or change in total revenue caused by change in quantity. So as Q approaches 0, that's us saying what is the derivative of total revenue with respect to quantity, right? So let's do that. We have that total revenue is 1,000 Q minus Q squared, and we're going to take that derivative with respect to Q. All right, so we have, yeah, we have this Q is raised to the power of 1. The formula for this derivative is to bring that power down, multiply it, and then subtract 1, right? So we'll bring 2 down and then subtract 1. So for the first term, we have 1,000, right? Oh, this is marginal revenue is equal to, so marginal revenue is equal to, we have 1,000 times 1 times Q raised to the power of 1 minus 1, which is 0, but we'll come back to that, minus 2, right? We're bringing that 2 down, times Q raised to the power of 2 minus 1. We can put these in parentheses too. Okay, so MR is equal to, remember that's our goal there, is equal to 1,000 times 1 times 1, where anything raised to the power of 0 is 1, right? Anything raised to the power of 0 is 1. Okay, minus 2 times Q raised to the power of 1. Maybe I shouldn't skip that step. All right, times Q raised to the power of 0, which is equal to 1,000 times 1 minus 2 times Q to the power of 1, which is 1,000 minus 2 times Q, right? That's marginal revenue. Marginal cost, so we know what marginal revenue will be for any level of Q. We don't have to create that table where we have 0 through infinity. We know what a marginal revenue will be as Q goes from 0 to infinity. Okay, so marginal cost is a derivative of total cost with respect to Q. Total cost from our question is 500 plus 50Q. All right, so this is a derivative of 500 plus 50 times Q divided by, or with respect to, excuse me, the derivative of this function with respect to Q. We'll note that this has no Q next to it, so it's just going to go to 0. This is a 1 that's going to come down, and we subtract 1, which means that our derivative here is going to be 0 plus 50 times 1 times q raised to the power of 0. Excuse me. Right? So that's just 50. Right? Because again, remember this goes to 1. All right. So marginal cost is equal to 50. So we have our two main equations that we need to be able to find that Q star, right? The Q that maximizes profit. So we have MR is equal to MC. That would be 1,000 minus 2 times Q is equal to 50. Solve for Q. Right. So we have 1,000 minus 50 is equal to 2 times Q. Therefore, Q is equal to 950 divided by 2, which is 4. Actually, I'm going to write that separately because this is a key moment. So, all right, we have that our Q star is 475 units. Okay, so in order for this firm that has this demand function and this cost function, this demand function here, and this cost function here, to maximize profits, they need to produce an output of 475 units. This is a monopoly firm. So what price should they charge to get P star? Plug in Q star into, or plug Q star, really, into our price function or demand function, where P is equal to 1,000 minus Q, right? So P star will be equal to 1,000 minus 475, which means that they should charge $525 for each of these 475 units. Wonderful. So what we've done here is parts A and A, right? Q and P. Next we have, what is that? Profit. Using up all my space here. So profit is equal to, let's draw a line. So this is part B. Where were we? Profit is equal to total revenue minus total cost, right? So the total you get in minus the total it costs you to get there. So this is P times Q, right? Minus the total cost function. We already already know what that is, but let's just plug numbers in. Yeah, minus total cost. So this would be equal to P of 525, right, times Q of 475 units, minus the total cost function is, remember from the question, 500 plus 50Q. Cool. So that is minus 500 plus 50 times, but we know what our Q star is, right? So we can plug that in, 475. So we have that this is equal to the calculators, 249,375 minus 24,250, all of which is equal to 225,125. This is the profit max for this firm. This is the best they can do, given their demand function in the market, like what they're facing in the market, and their cost function, what it's costing them to produce that. All right, so part C then goes on to say, well, what will profit be if we decided to go with the Q that wasn't Q star, right? And we said, let's go back 100, or let's go forward 100. So let's do that. So in part C, we'll start with Q, excuse me, that is less than 100, less than Q star, right? Therefore, we have a Q of, let's call this Q1. Q1 of 475 minus 100, which would be 375 units. Okay, so now let's figure out what that profit will be, but to do that we need to figure out the price I should change colors. We need to figure out the price that they can actually charge for this, right? Because remember, the firm is still at the mercy of the markets, the consumers. So for that quantity, price will be equal to 1,000 minus 375. Remember, we have our demand function or inverse demand function, or a function that tells us what price will be for any level of Q. All right, so this is equal to 625. Wonderful. So this is our P and Q. We can calculate profit. This would be equal to, remember, this is total revenue minus total cost. P is 625 times quantity of 375 minus 500 plus, this is the total cost function for this production, 50 times 375. Okay, so with that, we have that this is equal to $234,375 minus $19,250, which makes sense, right? They're selling, well, less stuff but higher price, so it's pretty close. And they're producing less stuff, which is why that cost is lower. However, let's see what the profit turns out to be. Well, this is $215.125 compared to our profit from above of $225, profit maximizing quantity, which gives us $225.125. $225,000 and 125. You know what I mean? This number, right? So when we compare, this is still max. This is still higher. All right, so we've seen that for less than. Maybe it will be different for greater than. Let's do that. So with Q greater than, with 100 greater than Q star, we have that Q will be equal to 475, which was our Q star, if you remember, right? 475 plus 100, which would be equal to 575 units. Again, we need to figure out the price that they can charge for this in the market. To do that, we just plug that into that demand function. So we have P will be equal to 1,000 minus 575 units, which gives us a price of $425. Wonderful. With this information, we can calculate profit. Remember, profit is total revenue minus total cost. So this would be equal to price times quantity minus 500 plus 50 times Q. Okay. So let's plug stuff in. So this would be equal to P is 475 times 575 minus 500. Now we're plugging this into the total cost function, right? So total revenue, total cost plus 50 times, which of these? That's right, Q, 575. Wonderful. So we have that this is 244,375 minus 29,250, which gives us 215 and 125, 15,125. Again, if we compare this to the original profit with that profit maximizing quantity of 475, we see that this is still max. So if we go either way, higher or lower in terms of quantity, we are still maximizing price at that profit, maximizing profit at that quantity of 475. Let's see what this means visually. So visually, if we were to draw the profit function, okay, profit and quantity, so we'll see how profit changes as quantity changes. We'll see that profit increases and then decreases. And at this point here, this is our profit max, right? This is the point where this line is tangent to, there's a line tangent just touching the curve, right? So this is where we're setting the derivative of profit is 0. What am I trying to say? At this point, right, if we go left from Q star or right from Q star, we will be dropping our profits regardless. And in fact, we saw that this max here was 225,125. We'll come back to this equal to 0 very soon. But we went forward 100. We went backward 100. We went forward 100. Right? And we saw symmetrical answers. Excuse me. For profits of 215,125. Right? They could not compete with this Q star that gets us to the peak of this profit mountain. Right? So now, why is this so special? Why is this term here of where the derivative is equal to 0? So there is no way that we can increase profit basically after this quantity is what this equation here is telling us, right? So we're saying that the derivative of profit, remember profit is total revenue minus total cost, with respect to Q needs to be 0, right? So if we apply these terms directly, the derivative of total revenue with respect to Q minus the derivative of total cost with respect to Q need to be 0, right? The derivative of total revenue with respect to Q is marginal revenue minus the derivative of total cost with respect to quantity is marginal cost. They need to be 0. So this is how we got this profit maximizing condition of MR is equal to MC. The firm cannot do better than when they are at this point. Okay? Very important takeaway for you from this particular course. I mean, we're looking at it here in this topic, but it shows up everywhere, especially when we're dealing with the market. Interaction between firms and consumers, where firms want to maximize profits.